Okay, it's time to start Chapter 6, and today we're specifically talking about different operations that we can perform on functions. This is mostly review on how we add, subtract, multiply, and divide functions, which is our first objective here, and then a reminder about what it means to compose functions, which is where you plug a function into another function. Alright, so look out for composition of functions in the second half of this video and make sure you understand the difference between composition of functions and multiplying or dividing, adding or subtracting functions. Alright, if we just take a look real quick at this example, this red line m of x represents Mr. Brooks' income, and the blue line f of x represents Mrs. Brooks' income, so the total income for their household would be f of x plus m of x. So both of these are functions. We can tell that they are lines. And if I add them together, I get this new line up here. So basically what we do is I take the y value from this function and the y value from this function, and that gives me my new y value at the same x value. That's what we're doing when we're adding or subtracting or multiplying or dividing functions. So it's super easy with the four basic operations. When you see this notation, this is f plus g of x. Remember, this is not times x. This means the function f and the function g added together and evaluated at x. And all we have to do is add those two functions together. Super easy. So if f of x is 2x and g of x is negative x plus 5, then f plus g of x is just 2x plus negative x plus 5, x plus 5. Same thing with subtraction, you just subtract the functions. Same thing with multiplying, and same thing with dividing. The only extra thing with dividing is that you have to make sure that you write down the restrictions in the denominator first. So for example, in this case, if I do f of x over g of x, I do 2x, like you see here, 2x over negative x plus 5. So what can x not be? X cannot be 5. If x is 5, then I get 0 in my denominator and my function would be undefined. So we have to write down the restriction that x cannot equal 5. So take a look at this example. Here I have f of x is 3x squared plus 7x. G of x is another quadratic equation, 2x squared minus x minus 1. So all I have to do to find f plus g of x is take my function f of x plus my function g of x and combine like terms. And so you end up with 5x squared plus 6x minus 1. Super straightforward. It's the same with subtraction. So here we're going to do f minus g of x. So I need to take f of x and subtract g of x. Of course, you have to be a little bit careful here. Make sure that you distribute that negative so that you don't mess up any of your signs. And when I do that, I end up with 3x squared minus 2x squared, which is x squared, 7x minus negative x, that's positive 8x, and then I have 0 basically because I don't have a constant here, minus negative 1, which is positive 1, and that's my final answer. Alright, you guys try this one. Your answer here should be A when you add f plus g of x, and try this one for subtraction. Okay, your answer here is D, negative x squared plus 2x plus 6. Alright, so I just wanted to show you real quick exactly what's happening again when we add. If we look here, f of x is x squared and g of x is x. Those are shown by the dotted graphs over here. And then the solid blue line you see here is f plus g of x. So look at what's happening. At x equals negative 3, f of x is 9 and g of x is negative 3. So f plus g of x, I just add my y values together. 9 plus negative 3, which is 6. So my new point is now negative 3, positive 6 right here. And I would do the same thing for all of my y values. My x stays the same, and I just add my two y values together to get my new function, or I subtract my y values, which you can see down here in the second graph. So I'd encourage you to take a look at that a little and make sure you understand what's going on. Oh, one last thing I wanted to show you here. In example 1 and the examples we've looked at so far, both of our functions have had the same domain, which is all real numbers. My resulting functions, after I added and subtracted them, also had domains for all real numbers. So like I said before, we have to be careful when we divide. We have to make sure that we look at our restriction. What is excluded from our new domain? All right, so when I multiply, multiplying is the same as adding and subtracting. So in order to multiply two functions, f times g of x, I just take f of x times g of x. So in this case, f of x is this function and g of x is this function. I multiply them. And then we distribute. Here they're showing you each term times x minus 4. They're like distributing 3x squared times x minus 4, negative 2x times x minus 4, 1 times x minus 4, and then they distribute all of those one by one. You can also do it term by term if you want and do 3x squared times x, 3x squared times negative 4, and then negative 2x times x, negative 2x times negative 4, and then 1 times x, and 1 times negative 4. It's up to you. And then you combine like terms, and we end up with 3x cubed minus 14x squared plus 9x minus 4, and that's our final answer. All right, with division, f over g of x, depending on the situation, you may or may not be able to simplify very much. So I'm just going to set up my quotient of f of x over g of x, which looks like this. And then I have to make sure again to write my restriction. Since my denominator is x minus 4, x cannot be 4. Otherwise, it would not be defined. All right. Again, just talking about the domain. 4 is what makes the denominator 0. So when we say x cannot equal 4, we're excluding it from our new domain, from the domain of our new function. Okay, you guys try this one. All right, your answer here should be C. And try this one with the division. And your answer here is B. You couldn't do any extra simplifying here because this does not factor, so you can't factor and cancel, but you do have to make sure that you write that x cannot equal negative 2. All right, now we're going to move on to the second main idea in this section, which is called the composition of functions. This is different than adding, subtracting, multiplying, and dividing. This is plugging one function into another function. And this has very specific notation. Remember, this is the one that looks like it says fog, but it really means f of g of x. So we would read this as f of g of x. So you'll either see it like this with the fog, or you'll see f, and instead, remember that f of x is usually like this, right? But basically what we're doing is we're saying instead of the x, we're going to plug in an entire function, g of x. So that's what this notation here means. So look what's happening. Basically what we're saying is we have a function, right? And when we're doing composition, we work from the inside out. So we start with our x, right? And we're going to plug x into our g. So we have our x and we plug it into g and we get an output, right? So if x is 3, let's say, and we plug it into g of x and we get 7. So this y value, this output of g, becomes the input or the domain of f. So I plug 3 into g and I get 7. Then I plug that 7 into f and I get my final answer, whatever that is. So I take the domain of g and I plug it in and I get the range of g. The range of g becomes the domain or the input of f, and then I get my range of f. So let's look at what that would look like. We're going to look at two examples. We're going to look at an example just with ordered pairs, and then we're going to look at an example with the whole expression that is the function. Okay? So here we have f of x is these 4 ordered pairs right here, this set of ordered pairs, and g of x is this set of 4 ordered pairs. So we're going to find f of g of x, and then we're going to find g of f of x. So follow through this with me, right? If I'm starting out with f of g of x, remember we work inside out, so we start with g. So I'm going to start with g. If I plug 7 into g, I get 0. That's what an ordered pair means, right? If I plug in 7, I get 0. Now remember, my output of g becomes my input of f. So if I plug 0 into f, what do I get? Negative 1. So my new ordered pair is 7, negative 1, because 7 takes me to 0 in g. Then I plug 0 into f, and I get negative 1. Let's do that again with the next ordered pair. again, we're starting with g and working out to f. So if I plug -1 into g, I get 7. If I plug 7 into f, I get 7. So this ordered pair is 7, 7. Let's do another one. If I plug 4 into g, I get 9. If I plug 9 into f, I get 4. So my new ordered pair is 4, 4. Whoops, I think I messed up on this one before. Sorry. Let's look at that one more time. -1 takes me to 7. 7 takes me to 7, but I started by plugging in -1, so this ordered pair would be -1, 7. And let's do our last one and see if it works. Starting with g, if I plug in 8, I get 2, and if I plug in 2, I get 6. So my new ordered pair is 8, 6. Because remember, I'm taking x and I'm plugging it into g, then I'm taking the result of that and plugging it into f. So this set is my f of g of x. All right, so now I'm going to erase some of what I did and I'm going to show you g of f of x. Okay, so g of f of x, I've changed the order, right? So this time I'm going to plug x into f. So I'm going to start with f, and then what I get from f, I'm going to plug in to g. So let's start with f. If I plug 2 into f, I get 6. Can I plug 6 into g? Is 6 part of the domain of g? No. So that ordered pair doesn't lead me anywhere, and that's fine. All right, what about 9? If I plug 9 into f, I get 4. Can I plug 4 into g? Yes. If I plug 4 into g, I get 9. So I went from 9 to 4 and 4 to 9, so my ordered pair is 9, 9. All right, let's try another one. 7, 7. If I plug 7 into f, I get 7. And then I take this 7 and I plug it into g, and I get 0. So my ordered pair for that one is 7, 0. And one more. If I plug 0 into f, I get -1. If I plug -1 into g, I get 7. So my ordered pair is 0, 7. So this set of ordered pairs would be my new g of f of x. Notice I only ended up with 3 ordered pairs. That's totally fine. Okay, now we're going to see what this looks like when we do the whole function at once instead of just individual ordered pairs. Okay, so we're going to start with f of g of x. Sometimes it helps me to think about it with the other notation, f of g of x. And actually, I'm going to write over this with a different color. Because really what this means is that into f, I'm plugging g of x, right? So f of x is 3x squared minus x plus 4. What I'm doing is I'm replacing this x with 2x minus 1 because that's what g of x is, right? G of x is 2x minus 1. So everywhere I see an x, I'm going to put 2x minus 1. It's exactly like substitution. So f of g of x is really f of 2x minus 1. I'm just plugging 2x minus 1 in. So that's 3 times 2x minus 1 quantity squared minus 2x minus 1 plus 4. So notice, everywhere there was an x, I replaced it with 2x minus 1. And there's the work to get to your final answer. So this 12x squared minus 14x plus 8 is f of g of x. Okay, now we're going to do it the other way, g of f of x. So this time it means I'm plugging f of x into g. So g of 3x squared minus x plus 4. Why? Because f of x is 3x squared minus x plus 4. So I'm just substituting that in for the x in g of x. And remember, g of x is 2x minus 1. If we come back here, just a little reminder, g of x is 2x minus 1. So what this means is that wherever I see an x, I'm going to replace it with 3x squared minus x plus 4. So that looks like this. This is where the x used to be. I replaced it with the other function. And then I just simplify, and I have my final answer. And then notice here in the final answer, my domain would still be all real numbers for the one we just did, but I would have to do a little bit of figuring out of my range because I know this is a parabola that opens up. So I would need to find the value for which y always has to be greater than or equal to that. So I would need the y value of the vertex to figure out my range. Okay, you guys try this one. All right, the answer here is A. And last one, your answer here is C. I'll see you in class to practice.